Hello, we're going to look at how to determine binomial probabilities and Poisson probabilities using Statcrunch. So let me share my screen here. All right, on Statcrunch, if you go to Stat Calculators, that's where you'll find all of the different calculators for the probability. Let's look at binomial first. So choosing binomial, we have the options to put in the number of trials, the probability of a success on any one trial, and then we can manipulate the probabilities that we're looking for. So let's say that we have a 30% chance of selecting a student in the class who has blue as their favorite color. From that survey that I did earlier in the semester, 30% of the students said blue was their favorite color. Let's suppose that we sample 20 students. So N is 20, I'm sampling 20 students, and the probability of a success that they like blue as their favorite color is 0.3. So I'm going to put in those parameters. N equals 20, probability of a success on any one trial, meaning selecting a student, is 0.3. And suppose I want to know the probability that exactly 6 students in my sample have blue as their favorite color. So we're going to look at the probability that X is equal to 6 and compute. And we find that probability is about 19%, 0.19163898. Okay, so if we randomly pick 20 students, probability that exactly 6 of them say blue is their favorite color is about 0.19. Suppose I want to know the probability that more than 6 in the class, in that sample, have it blue as a favorite color. All I do is change the sign to greater than and hit compute again. And we see that it's 0.39. So 39% chance that more than 6 people in that sample of 20 will say that blue is their favorite color. Okay, so you can manipulate the symbol, greater than, less than or equal to, whatever, equal to, and the number of successes that you want, as well as setting the parameters. All right, let's look at Poisson. So if we go to the calculators again, and this time choose Poisson, it works very much the same way. Obviously, it would have to be a different scenario. So let's say we're looking at counting the waves that hit a beach. And we know that the waves hit the beach on average 1.8 waves per minute. So our mean would be 1.8 waves per minute. And let's say we want to know how likely is it that in a particular 1 minute time interval, exactly 2 waves hit the beach. So we'll change this to equals 2 waves and compute. So there's a 27% chance that exactly 2 waves hit the beach in any minute that we sit on the beach and count waves. Suppose we want to know how likely it is that 2 or fewer waves hit the beach. So X is less than or equal to 2. Well, there's a 73% chance that 2 or fewer waves hit the beach in that minute that we're counting waves on the beach. Hope that helped.